module 2, we need to import the CSV file and create data frames from the data and create a graph from the data and do graph operations such as finding out the vertex in degree and vertex out degree, in degree and out degree of each vertex in the graph. And we should remove the duplicate data. We need to name the columns and create output data frame, and we need to display some vertices and edges and even apply the motif findings. So let us look into the code. Initially we are taking a CSV data and it is of CSV format, and we want the header, and we are loading it into the trips underscore data frame df. And the trips data has data about the trips, the start location and the final destination. And the next data that we are loading is the data about the stations, each station. And even this data is of the CSV format, and we are loading it into station underscore df. We are printing the schemas of the two data frames, trips underscore df dot print schema and station underscore df dot print schema. We are creating a temporary view for trips, and the first stations, the view for the trips underscore df, the name is trips, and the view name for station underscore df is stations. And using this and on stations df, we are selecting the column dog count and distinct number of distinct, and we are doing the show. And then next, using the views, we are writing the select statements over here. We are selecting the whole data from the view into end station and the whole data from the trips into end trips, and we want to create the vertices now. So the vertices are created from the stations, so we are using the end station, and we are renaming the column from name to ID, and we are selecting only the distinct stations. So each distinct station would now be a vertex and is stored in station vertices. Similarly, we need to create edges. So we are taking the end trips and we are renaming the column start station to source and the end station to destination. And this would be having all the edges. And now we are creating a graph using Graphframe, and we are giving vertices as the station vertices and the trip edges as the edges. Later we are concatenating the latitude column and the longitude column with space, and we are renaming this as location, and we are showing the 10 records. We want to print the total number of stations, so for that we are directly taking the vertices count. In the graph we are selecting the vertices and we are counting the vertices. And if we want to select the total number of distinct stations, we are applying distinct over here on the vertices. And for the number of trips in the graph, we can count the edges. So we are taking the station graph edges and count. And for distinct trips, we are applying distinct. And if we want to calculate the number of trips in the original data, then we are going to do it on the end trips data. So this has been the original data, so we are doing count over here on the end trips. We are doing the vertices dot show and the edges dot show. On the graph, if we give in degrees, it is directly going to give us the in degree for each vertex, and we are displaying only, we are ordering by descending based on in degree, and we are displaying only 5 records. Similarly, we are doing out degree, and we are finding the motifs in the graph, and we have given this for the motifs and we are showing it. And then next, we are the degrees in the on the graph will sum up the in degree and out degree and will be displayed. So we are even ordering the degree in descending order and then displaying only 5 records. So to find the highest destination in the graph, we are taking the cells, grouping by source, and for each source we are grouping by destination for source and destination. and then we are grouping by source and destination. So from this source to destination, how many records we are getting, then we are counting, and we are ordering based on in the descending order of the count, and displaying only top 10 records with the highest destination. And then for degree ratio, I mean, initially we are taking the in degree table and the out degree table that we have fetched in the above steps. Over here we are getting in degree table for in degrees and out degree table for out degrees. Now we would like to join the in degree and out degree with the common column, that is ID. We are joining, the joining condition is in the both the tables the ID should be equal. After joining on the ID, we are dropping out the column ID. Since it is present in two tables, we are dropping out in one table. And then the select expression is that we are doing in degree by out degree. We are taking this as degree ratio, and we need to do the order. Yeah, we are doing this over here. Then the next thing is that we are going to order the records based on the descending order of the degree ratio, because the more the in degree and less out degree we need for the requirement. So the value would be more when the in degree is more and the out degree is less. So we are doing the order of descending of the degree ratio, and we are displaying the top 10 records. Let us run this file and see the output. Yeah, and this is the code related to ICP5, and once the task runs, we can see the output. It is running the build. Yeah, this is the schema structure of the trip data. It has the trip ID, the start destination, start station, and end destination, and this is about the station. It has a name, station ID, and latitude, location, and this is the dog count for each station. Then moving on, we are concatenating the latitude and longitude with space, and we are giving it as a location. And the total number of stations we got is 70, and total number of distinct stations is 70. Total number of trips in graph is given over here, distinct trips and the original data, so there are no duplicates actually. Then this is the data about the stations. We are limiting it to 20 rows. This is the data in the trips table, and we are limiting it to 20 rows. Then for each station we are displaying the in degree, followed by each station we are displaying the out degree. This is about the motives, and this is where we are summing up the in degree and out degree and displaying it as degree for each station. Then we are for each station, we are for source and destination we are giving the count from this grouping by the source and destination. Then this is the degree ratio, and we are displaying in the descending order of the degree ratio. This is all about the ICP5.